Recall that when we have a line that is tangent to a circle intersecting a radius, they intersect to form a right angle. So I have a tangent line, AB is tangent, they tell me that in the problem, and I have the radius drawn in there, so I know that I'm gonna have a right angle right there, which forms a right triangle. The question then asks me to find the radius of this problem, and once again, good old Pythagorean theorem to the rescue. I've got a right triangle, and so I can use Pythagorean theorem to find out what's missing. Well, the two legs of the triangle are r and 80, so I can begin writing my equation as r squared plus 80 squared. But as soon as I get to write the hypotenuse squared, this is where the problem becomes a little bit different. My hypotenuse is not r, nor is it 50. Instead, the hypotenuse is the sum of those two segments. So my hypotenuse is actually r plus 50, or 50 plus r. Not 50r, 50r means 50 times r. So the entire hypotenuse is r plus 50, which means back in my equation, that's what needs to be squared, r plus 50 squared. Okay, so to do this, we're going to have to kind of take a stroll down memory lane and remember a few things about algebra. So let's kind of do that off to the side. Firstly, what we never ever wanted to do is we cannot distribute an exponent. It does not work that way. So we are not going to do that. We cannot distribute. Instead, and again, let's kind of do this work off to the side a little bit. What I want you to think about is what r plus 50 squared means. To square something means to multiply it by itself. So really what this problem is asking us to do, or this part of the problem, is to say r plus 50 times r plus 50. So that's what I need to multiply together. Now in Algebra 1, you probably did this a few different ways. You may have used FOIL. You may have talked just about distributing. What I like to do, though, is I like to use what I call the box method to multiply these two binomials together. So I'm going to draw a 2x2 box like this, kind of like a window, and then outside of the box, I'm going to write what I'm multiplying together. So r and positive 50, and then r and positive 50. And what I'll do is I'll fill out the box by multiplying rows and columns together. For example, r times r is r squared. 50 times r is just 50r. Down here I've got another 50r. And then finally, 50 times 50 is 2,500, 2,500. So that's what I get when I multiply those two pieces together. Taking this back to my equation then, I'm going to pull those numbers out of the box, and I'm also going to add up any like terms that I have. So I've got the r squared in front, plus I'll have 100r when I add those two 50r's together, and then plus 2,500. So that was kind of our little detour we had to take back to Algebra 1. Getting back to this problem, then I'm going to finish writing what I had on the left. That's r squared plus, well, 80 squared is 6,400. So it looks like at this point I have something that's quadratic. It's got x or r squared in it. So I may be thinking I have to use the quadratic formula, but that's not the case. If I try to get the r squared to the same side by subtracting r squared, what's going to happen right away is they're just going to cancel out. So I don't even need to worry about anything being quadratic. I don't have to worry about that just yet. They just cancel out. So then finishing like normal, let's subtract 2,500 from both sides. 6,400 minus 2,500 leaves me with 3,900, 3,900, equal to 100r. If I divide both sides by 100, I find my radius. It turns out to be 39.